आज हम केमिकल बॉन्डिंग का वीडियो नंबर 2 लेकर आया हूँ। ये वीडियो बहुत इम्पोर्टेंट है ऑर्गेनिक केमिस्ट्री और इनऑर्गेनिक केमिस्ट्री के लिए। टॉपिक है हाइब्रिडाइजेशन। चलिए वीडियो स्टार्ट करते हैं। द चैप्टर नंबर 4 ऑफ क्लास 11 केमिकल बॉन्डिंग, द प्रोसेस ऑफ डिटर्मिनेशन द हाइब्रिडाइजेशन ऑफ सेंट्रल एटम in a particular given compound. This is the various step method. Method num first determine the method number 1 which can help the determination of hybridization of central atom. Method 1, hybridization denoted by capital H. Hybridization denoted by capital H. The formula of hybridization, half into third bracket of valence electron of central atom plus number of surrounding atom minus cationic charge plus anionic charge. This is the formula of hybridization. Both case in the formula, both case cationic and anionic charge. Both case cationic and anionic charge will be modulus value given. What is the meaning of this line? Both case cationic and anionic charge will be modulus values be given. If anionic charge Cl minus, then the charge of anion -1, but -1 is not given. Always modulus value is given. That means anionic as cationic, both case always positive value is given. That modulus means positive value is given. Determine of central atom in a chemical compound. In a particular compound, which atom is central atom? What is the procedure for determination? Less number of atom in a compound is known central atom. In a particular compound, the less number of atom is known as central atom and the remaining atoms are surrounding atom. As example, NH4 plus, this compound less number of atoms nitrogen due to presence of one nitrogen atom. So nitrogen is central atom. So nitrogen is central atom and the remaining atoms, that means 4 hydrogen atom, this is the surrounding atom. What is the hybridization of central atom? The central atom denote star mark is central atom and remaining are surrounding atom. Always hybridization can determine only central atom in a compound. So the hybridization of N in NH4 plus ion, you apply the formula hybridization H is equal to half into central valence electron of central atom. Valence electron of central atom, that means the central atom nitrogen. Valence electron means outermost orbital, the number of electron present in outermost orbital. N, total atomic number nitrogen 7, so first orbit 2, next orbit 5, so the outermost orbit electron 5. This is the outermost electron and also known as valence electron. So valence electron central atom 5 plus number of surrounding atom hydrogen, how many number? 4, minus cationic charge 1 plus, that means only modulus value is given, minus cationic charge plus, that means 1, plus anionic charge not present, 0. So hybridization number half into 8, that means 4. So this is the hybridization number 4. What is the name of the hybridization of N atom? Then your syllabus, the name of hybridization, SP, so name of hybridization SP when H is 2, hybridization number 2, 1s 1p, total 2p, 1s 1p, that means total 2p, total 2 orbital, 1s orbital, 1p orbital, total orbital 2. This is the hybridization number. If hybridization number is 2, then the name of the hybridization SP. sp2, 1s orbital, 2p orbital, that means total 3 orbital, so hybridization number 3. If hybridization number is 3, then the name is sp2. Then sp3, 1s 3p orbital, total orbital 4, so if hybridization number is 4, then name is sp3. Next, sp3d hybridization name when, in which condition? If H is 5, that means 1s orbital, 3p orbital and 1d orbital, total 5 orbital. sp3d2 when H is equal to 6, you can check the number 1s, 3p and 2d, total 6 orbital. Next last is sp3d3 when hybridization is 7. And the special type of hybridization name dsp2 and d2sp3. What is the shape of dsp2 hybridization? Square planar shape. dsp2 shape square planar. dsp2 coordination number for hybridization 4. d2sp3 shape octahedral. Coordination number of dsp2 which atoms are occupied in hybridization d2sp3, then it is coordination number 6. Next is I discussed about dsp2 and d2sp3 hybridization at the last time. First time this syllabus sp, sp2, sp3d and sp3d2, this is the main year syllabus. Next finally we discussed dsp2 and d2sp3. Then the example, then the NH4 plus, the hybridization of central atom, hybridization number, you calculate this method, this is 4. So if hybridization number is 4, then hybridization name sp3. So central atom in NH4 plus, which hybridization state belongs to? sp3 hybridization. Next your question, first process, the determine the hybridization number according to this method, then hybridization number is 2, then the name is sp hybridization, 3 sp2, this order. So hybridization number for NH4 plus 4 hybridization, if hybridization number 4, then hybridization name sp3. So in the species NH4 plus, the central atom in which state belongs to hybridization? sp3 hybridization. Next, the shape and the geometry of particular compound. What is the shape and the geometry of particular compound? And they are present bond paired, lone paired electron. I about discuss next topics, the shape and the geometry, the bond angle and the presence of bond pair and the lone pair electron. Please this note will be written on your copy. First time again I discuss method 1. First time you calculate hybridization number. Hybridization number making procedure, half into valence of central atom plus number of surrounding atom minus cationic charge plus anionic charge. Must be kept in mind, always cationic charge and anionic charge are given modulus value, that means positive value is given. Determine the central atom in a chemical compound. Which atom is central atom in a chemical compound? You identify the less number of atom in a compound is known as central atom and the remaining atom is surrounding atom. Then first the hybridization making procedure, this is the hybridization number making procedure. Then what is your syllabus of hybridization name? This is the name of hybridization name. If 1s 1p, that means total 2 orbital is given, so hybridization number is 2. If hybridization number is 3, 1s 2p, total 3 orbitals, so hybridization number is 3. According to the hybridization number, the name also be given this table according to hybridization number. Next topics I discuss about the geometry, shape and the bond pair and the lone pair electron. The geometry of compound, the geometry of the chemical compound depends only bond paired electron, depends only bond paired electron, but the shape of the molecules, but the shape of the compound depends on both bond pair and lone paired electron, bond pair and lone paired electron. Bond pair and lone paired electron. If in a compound, L pair, that means lone pair, L paired electron absent, then its geometry and shape also same. Geometry and shape also same. What is the three notes must be kept in mind. The geometry and the geometry of the chemical compound depends only bond paired electron. In a particular compound, we know that the Lewis dot structure, the number of bond paired electron and the number of lone paired electron and their formal charge. The bond paired electron, the geometry of the molecules or compound only depends bond paired electron, but shape of the compound depends on both bond pair and the lone paired electron. Last point, if in a compound lone paired electron absent, then this compound geometry and shape also same. That means if lone pair absent in a compound, its geometry and shape also same. This theory, which hybridization and what is the bond paired electron and what is the number of lone paired electron present in a compound and their shape, what is the shape and what is geometry and their bond angle, also given from VSEPR theory model. Very important for this instruction, for geometry, shape and number of bond pair electron and the number of lone pair electron present in a compound and their bond angle and hybridization name. This all data can be given from VSEPR theory. VSEPR theory table we can be write on the board. This table must be always remember for the hybridization making. This table also can help you for the process, for the hybridization process. Hybridization name, geometry, shape, bond paired electron, lone paired electron, next bond angle, This is the VSEPR model, VSEPR theory. This is the VSEPR theory. Making table, hybridization name, what is the geometry of the compound, what is the shape of the compound, number of bond pair electron present in this compound and the number of lone pair electron present in this compound, then the bond angle. First time we discuss about one more procedure for the making hybridization number, that means H is equal to number of bond paired electron hybridization number making by number of bond paired electron plus number of lone paired electron. In a compound, total number of bond pair electron and total number of lone pair electron at, then you can give the hybridization number. Hybridization number is given another procedure, number of bond pair electron plus number of lone pair electron. Two types of electron can be added and the final result should be help you for making hybridization number. Then this node can also, please note this point, what is the hybridization number making second procedure, number of bond pair electron plus number of lone paired electron. Two number are added, then the final result is hybridization number. According to hybridization number 2, then the name is sp. Hybridization number is 3, the name is sp2. This is the procedure. Next, the model of VSPA theory. If hybridization name sp, then means hybridization number 2, so name is sp. What is the geometry? Linear, shape also linear. What is the bond paired electron? 2. If bond paired electron 2, then the lone paired electron 0. 2 plus 0, bond paired plus lone paired electron. At 2 plus 0, that means hybridization number 2. That is hybridization number 2. Bond paired plus lone paired electron added. 2 plus 0, 2. So hybridization number is 2 and the name is sp. What is the bond angle? Linear means 180 degree. Then hybridization name sp2. What is the 1s2p? That means total 3 orbital. So hybridization number is 3. Shape and geometry. Totally bond pair and lone pair, shape depends on bond pair and the lone pair electron. Hybridization number 3. So the probability of 3, lone pair 0. We know that hybridization is equal to bond paired electron plus lone paired electron. If bond pair electron 3, lone pair electron 0, then plus the result 3, hybridization number is 3. 3, 0. If bond pair electron 3, lone pair electron 0, then shape is trigonal planar. Shape also same due to absence of lone pair electron. If lone pair electron in a compound is absent, then the geometry and shape also same. So this shape also same, trigonal planar. Bond angle 120 degree. Next procedure 3, 0. We can 2, 1. If bond pair electron 2 and the lone pair electron 1, then total at bond pair electron plus lone pair electron sum is hybridization number. 2 plus 1, result hybridization 3. This is 3. Then geometry not change. Geometry cannot depend on the lone pair electron. Trigonal planar. But shape is changed due to presence of lone pair electron. So what is the shape? V shape or bend shape. Next hybridization sp3. 1s3p orbital. That means hybridization number is 4. So what is the possibility of 4? Hybridization number also can be given from bond pair electron plus number of lone pair electron. So 4, total result hybridization 4. So this is the possibility 4, 0. 4 plus 0, hybridization number 4. Second possibility 3, 1. 2 added, bond pair plus lone pair 4. Then next 2, 2. If lone pair is absent, then the shape and geometry also same. Lone pair absent. First case, lone pair absent. So the shape tetrahedral. Geometry and shape also same due to absence of lone pair electron. So this shape also tetrahedral. And then bond angle. What is the bond angle? For sp3 hybridization, bond angle 109.5 degree bond angle. But in this case, sp2, the V shape or bend shape, always not bond angle 120 degree. If the hybridization name is sp2, but its shape V shape or bend shape, then the bond angle will not be 120 degree. The bond angle depends on number of lone pair electron and their electrostatic repulsion between lone pair electron and the lone pair bond pair electron. But the shape of trigonal planar, that means if lone pair is absent, then always bond angle 120 degree. But in sp2 hybridization, if lone pair is present, then the bond angle always not 120 degree. It can be decreases or increases. sp3 hybridization, if 4-0 combination tetrahedral and bond angle 109.5 degree. For which case? If LP 0, if lone paired electron 0, then 109.5 degree. Remaining two cases are not always 109.5 degree. This is totally depends on lone pair and the lone pair bond pair repulsion. 3-1, what is the geometry? Geometry not change, geometry is same as it is tetrahedral, but shape pyramidal. If 2-1, bond pair 2, lone pair 2, so shape V shape. V shape, not geometry not change, tetrahedral. For sp3d, total orbital 1s, 3p, 1d, total 5 orbitals. So hybridization number is 5. Okay, what is the combination of 5? What is the combination of 5? We can also know that the hybridization number is the sum of the bond pair electron and the number of lone pair electron. So 5, total number hybridization 5. So we can probability 5 0, 4 1, 4 1 added 5 result, 3 2, 3 2 can added hybridization number 5, 2 3 also be given hybridization number 5. So save sp3d, save the if lone pair is absent, first case 5 0, if lone pair is absent, then the shape, first time the geometry trigonal bipyramidal, but short form what in pyramidal, that means TBP structure, TBP, trigonal bipyramidal. If lone pair absent, then shape also same, that means TBP. What is the bond angle? In this case, 3 bond angles are 120 degree and 2 bond angles are 90 degree. Trigonal TBP. Then if bond pair 4, lone pair 1, then the geometry not change TBP, but shape due to presence of lone pair shape change, that means seesaw. For 3-2 combination, shape also change. For 3-2 combination, shape T shape. If number of bond pair 2, number of lone pair 3, then the shape is linear. But geometry all case same. TBP. 4 case geometry not change, that means TBP. Next hybridization, sp3d2, hybridization number is 6, 1s, 3p and 2d, total 6 orbital. So its geometry for sp3d hybridization, geometry is octahedral. When in which condition octahedral geometry and shape are changed? If lone pair is 0, that means if bond pair 6, lone pair 0, total added result hybridization number 6 plus 0 6, then shape also same, octahedral. 5 1, if bond pair 5, lone pair 1, then not change geometry, but shape square pyramidal. If 4-2 combination, then shape change, square planar. Shape also depends on lone pair electrons, square planar. But shape not geometry not change. Geometry totally depends on bond pair, octahedral. This is a bond angle. Each case bond angle are 90 degree. Then remaining one, I discuss about the VSPR theory. If hybridization number is 2, then hybridization name sp3, geometry and shape in which condition linear. If lone pair is 0, we also know that hybridization can be determined in this process, bond pair electron plus number of lone pair electron. So total number of hybridization 2, that means bond pair 2, lone pair 0, this is the possibility. 2 plus 0 added hybridization number 2, then hybridization number is 3. So in each case, in which position lone pair is 0, in which position R belongs to lone pair is 0, then this the shape and geometry also same. In which position 0, geometry and shape also same. In which position lone pair is absent, geometry and shape is same. So the shape of the molecules only depends on the lone pair electron, number of lone pair electron and the number of bond pair electron, but geometry is not depends on lone pair electron. Then remaining are 1, hybridization name and bond angle. This is the remaining one, that is sp3d3. Remaining one are sp3d3. Last hybridization sp3d3. For hybridization number 3, total 6 orbital, 1 s orbital, 7. Hybridization number 7. Geometry pentagonal bipyramidal. Pentagonal bipyramidal. Shape also same, pentagonal bipyramidal. How many bond pair electron can be present? 7. Lone pair 0. Yeah, we also mentioned earlier, if lone pair is 0, shape and geometry also same. Pentagonal bipyramidal bond angle, 2 bond angle, one 72 degree and one others are 90 degree. So it is a total base pair theory model. Please remind this table always when you determine the hybridization procedure. This table helps also shape and the bond pair and the lone pair electron and also bond angle. The structure, when you draw the structure of the molecules or compound, the structure depends only geometry structure. When you draw the structure of NH4 plus or SO4 2 minus ion or H2SO4 in any species, you draw the structure, then the structure draw according to geometrical shape. Draw the structure according to geometrical structure. If structure, then what is the structure? Linear. Linear structure means for hybridization. When you draw the structure, hybridization SP hybridization. What is the shape? Shape linear. Shape linear. Geometry also linear. Geometry linear. Draw the structure always. Draw the structure always geometrical form. Geometrical form. SP linear means that is the linear structure for a particular species carbon dioxide. This is the sp hybridization. Then sp hybridization linear shape, carbon central atom, both side OO. Carbon valency 4 and oxygen also valency fill up 2. So this is the shape of linear shape. This is the linear shape. Bond angle 180 degree. Bond angle 180 degree. sp2 trigonal planar. Trigonal planar shape. Trigonal planar shape. What is the structure? Structure must be drawn from geometrical structure. Trigonal planar. If suppose a compound AB3 A belongs to sp2 hybridization. Suppose we consider A belongs to sp2, then what is the structure? Trigonal planar. This is the structure of trigonal planar. What is the bond angle? That is 120 degree and this is the 120 degree. For sp3 tetrahedral structure. Always draw the structure from geometrical form. Tetrahedral form, if for a particular species methane, CH4, this carbon belongs to sp3 hybridization. You can determine this procedure. We earlier this procedure, what is the hybridization number and what is the name? sp3. So this is the shape of tetrahedral. That means tetrahedral structure. This is the tetrahedral structure. This is the tetrahedral structure. What is the bond angle? 109.5 degree. 109.5 degree. Then sp3D. What is the shape of sp3D hybridization? What is the shape of sp3d hybridization? Trigonal bipyramidal. For PCl5, phosphorus belongs to sp3d hybridization. You can find this method PCl5. What is the structure of trigonal bipyramidal? Central atom, middle portion phi, remaining first time draw triangle. Central atom phosphorus, this is the position, this is the 3 position first time, and 2 position are always occupied vertical, upper and lower position. This position, these 3 position for the corner between the central atom and the corner of the triangle, 3 position are known as, these 3 position are known as equatorial position. Equatorial position. And the upper and the lower position known as axial position. So any structure, the central atom and the corner side position is known as equatorial position, and the always 2 position, one upper side and one lower side, 2 position is known as axial position. PCl5 surrounding atom 5, so each side Cl, first time 3 equatorial position are occupied 3 chlorine atom, then 2 remaining chlorine atom, upper portion and lower portion. This is the structure of trigonal bipyramidal. What is the bond angle? What is the PCl bond angle? 120 degree and 120 degree bond angle, which position? This is the angle 90 degree. This angle 120 degree. Two bond angle are 90 degree and 20 degree. This is the 90 degree, this 90 degree, and this is the 120 degree bond angle. Then the next is sp3d2 octahedral shape. What is the octahedral geometry? Parallelogram structure. What is the octahedral geometry? This is the form of TBP, trigonal bipyramidal structure. This is the structure of octahedral structure. Octahedral structure, suppose in a particular compound, this is the central atom X, this is the axial position, this is the equatorial position, and always upper position and lower position is called axial position. These 4 positions, central atom and corner position is equatorial position, and lower and upper position is called axial position. So any species, any atom, suppose A, B, C, D, E, F. This is the structure of octahedral shape. This is the structure of octahedral shape. Then last is, then this structure and the geometry will be noted in your copy. Next hybridization shape is, this is the sp3d3. sp3d3 shape, pentagonal bipyramidal. Shape, sp3d. What is the structure? Geometrical structure, pentagonal bipyramidal. This is the structure. Suppose IF7 central atom occupy sp3d3 hybridization. You can check this method. What is the central hybridization of central atom? sp3d. We previously you learning about the hybridization procedure. Pentagonal bipyramidal structure. Central atom iodine. These position are known as central atom, and the corner position is known as equatorial position, and always 2 remaining are upper and lower side. This is the position of axial position. This corner side position is known as equatorial position. IF7 surrounding atom 7, 1, 2, 3, 4, 5, 6 and 1, 7, IF7. This is the structure of pentagonal bipyramidal. What is the angle of 72 degree? This is the angle of 72 degree. What is the angle of 90 degree? This means this is the angle 90 degree. Two bond angles are occupied in sp3 hybridization, 72 degree and 90 degree. This is the 72 degree and this is the 72 degree. This is the 72 degree and this is the 90 degree angle. So it is the total structure of and the shape of the geometry for a particular compound. Then the next method number 2 for short topics. For short topics, then you remember the position of lone pair, the position of lone pair electron, the position of lone pair electron in a geometrical structure, that means if central atom occupy the lone pair electron, then the lone pair electron position, which position, equatorial position or axial position, which position can occupy lone pair electron. What is the method of lone pair electron determination in central atom? Lone pair electron in central atom determination procedure, central atom is equal to H minus X minus D. What is H? H is hybridization number. X, number of monovalent atom, number of monovalent by univalent atom, monovalent or univalent atom. D, number of divalent atom. That means which atoms are valency 2, divalent atom. Suppose NH4 plus. Example NH4 plus. NH4 plus we earlier considered the hybridization is sp3 hybridization. So this species hybridization number 4. You know that sp3 hybridization 1s3p, total 4 orbital. So hybridization, if hybridization number is 4, then the hybridization number is sp3. Hybridization number is 4. Number of monovalent atom. Monovalent means in which atoms are occupy valence electron 1. Hydrogen are monovalent, hydrogen valency 1. So number of monovalent atom, total number of monovalent atom, number of 4 hydrogen. So number of monovalent 4. D, number of divalent atom. In these molecules, nitrogen valency 3, hydrogen valency 1. So there is no divalent atom. So divalent atom is 0. So we determine the lone paired electron in central atom is equal to H minus X minus D. That means hybridization number 4 minus X minus D. That means lone pair absent. So NH4 plus ion central atom has no lone pair electron. If lone pair electron present, if in a compound is central atom occupy lone pair electron, then the position of the lone pair electron must be maybe axial or equatorial. What is the possibility of axial and equatorial position? What is the procedure of axial or equatorial position? The position of the lone pair electron in a geometrical structure, if hybridization sp3, if hybridization sp3, lone pair always occupy lone pair position at equatorial position. If sp3 dehybridization, then lone pair position at axial position. Lone pair occupies at axial position. Equatorial position and sp3 d2, lone pair position at equatorial position. So sp3, if hybridization name is sp3, then lone pair always position at equatorial position. And sp3 dehybridization, always electron or lone pair electron are occupy axial position. For a particular structure in a particular compound, if octahedral shape, if we draw the octahedral shape, this is the central atom, this position is known as this method are lone pair electron position at axial position, if hybridization is sp3d, then equatorial position, occupy equatorial position, then sp3d hybridization, then lone pair always axial position. This is the structure of octahedral shape. This position, this corner position, this four corner position is named as equatorial position, and one upper and one lower position is known as axial position. So hybridization, if the nature of hybridization sp3, then always lone pair are occupied at axial position. sp3d hybridization, lone pair are occupied equatorial position. What is equatorial and axial position? The central atom and the corner position is named as equatorial position, and one upward direction and one downward direction, two positions are known as axial position. For a particular example, next method for determination of hybridization process is short tricks. For short tricks method number 2. Method number 2. Suppose example we given NH4 plus. What is the hybridization number? This is the hybridization, central atom hybridization. First time, step 1. First count total number of valence electron of each atom in a compound, Then step 2, first step 1, then step 2, if total number of valence electron less or equal to 8, then hybridization is age is numerical number of total valence electron divided by 2. Point number 1, if total number of valence electron greater than 8 to less or equal to 56, a range this limit, if total number of valence electron limitation greater than 8 to less or equal to 56, then hybridization number age is numerical number of, if total number of valence electron greater than 8 to less or equal to 56, then hybridization is numerical number of counted valence electron divided by 8. Suppose NH4 plus 1, as an example NH4 plus 1. First count total number of valence electron for NH4 plus 1, total number of valence electron for NH4 plus. Suppose example NH4 plus. NH4 plus ion. Total number of valence electron of each atom. That means nitrogen valence electron 5, hydrogen valence electron 1, number of hydrogen atom 4, 1 into 4. The upper side charge plus 1. The upper side charge plus 1 means 1 electron deficient. So total number of valence electron 8. What is the number of total valence electron? Which limit? First formula, the if total number of valence electron less or equal to 8, then the hybridization number is the numerical number of total valence electron. That means the counted valence electron divided by 2. So the total number of valence electron in NH4 plus ion 8. So these rules follow. The rules number 1, this is the rules number 1, and this is the rules number 2. So these follow rules 1, these follow rules 1. Then hybridization number H is equal to counted number of total valence electron. That means counted number of total valence electron 8. This limit can follow this range less or equal to 8. So the hybridization number is numerical number of total valence electron. That means counted valence electron divided by 2. So result 4. Hybridization number is number 4. So the name is sp3 hybridization. This is the procedure. This is the short trick procedure for hybridization of central atom in a particular compound. Next example. PCl5. Suppose we consider PCl5. Step 1. First counted number of valence electron. So number of valence electron is equal to, first time phosphorus valence electron 5, chlorine valence electron 7, into number of chlorine atom 5, 1 chlorine valence electron 7, total number of 5, 7 into 5, PCl5 total 35, in the total number of electron 40. So this range can follow second rules. We know that if total number of valence electron between greater than 8 to less or equal to 56, bit more much in between greater than 8 to less or equal to 56, then hybridization H is equal to counted valence electron for PCl5 40. This is the counted valence electron 40 divided by 8. So result is 5. That means hybridization is sp3 dehybridization. If you counted number of lone pair electron in central atom, that means hybridization number H minus number of surrounding atom. Hybridization number surrounding atom. Hybridization number 5. Surrounding atom chlorine 5. So there is no lone pair electron. So this is the making procedure of number of lone pair electron in a central atom. Hybridization number minus number of surrounding atom. Hybridization number is 5, the lone pair is 0, so 5 0. This is the 2 process. If 2 limit, if less or equal to 8, second is greater than 8 to less or equal to 56. Suppose another example, if total number of, suppose total number of valence electron in a molecule or compound, 36. if we consider, suppose total number of electron you counted, the result is 36, then what is the range limit? It's the second rules, if the total number of valence electron greater than 8 to less or equal to 56. So hybridization number is 36 divided by 8. What is the procedure of dividing procedure? Dividing procedure is normal, this procedure, this is the special case. Hybridization of dividing procedure, 36 by 8. This is the normal procedure of dividation. Always follow the normal procedure. 8, 8, 4, 32. Result, remaining 4. So the remaining result, always the remaining result can be divided by 2. Always kept in mind, this is the special type of dividation process. 8, 4, 32. Remaining portion result 4. Always remaining result always divided by 2, not others number. Always remaining result are divided by 2. Others number cannot be allowed it. So 2, 2, 4, result 4. So these the two results are added, 4 plus 2, that means 6. So this is the hybridization number, that means sp3d2. That means sp3d2. Suppose next case, if you counted total valence electron in a compound 42. Suppose you counted total number of valence electron 42. Then hybridization number, follow second rules, 42 by 8. This dividing procedure is totally normal procedure. 42 divided by 8, 8, 5, 40. Remaining portion 2. We again remind the remaining result, that means the remaining portion 2 always divided only number of 2, otherwise can be result is 0. Always the remaining result always divided by only number 2. 2, 1, 2 cancel. So the final 2 result 5, 1 added, 5 plus 1 6. So hybridization name sp3d2. This is the special type of this procedure and special type of dividing procedure. This procedure only follow this mechanism, otherwise the result can be wrong. Always remaining this portion, the remaining result always divided by 2, not others number, then the final result is sp3. This is the complete hybridization procedure and shape and geometry. Next video we discuss about a particular species and their structure and the distribution of the lone pair and the bond pair electron. So thank you very much.